Hello, my name is Pedro Morales. I'm a teaching professor at the math department at the University of California in Santa Cruz, and this is Math Talk. This week, we talked about very important concepts in linear algebra and precalculus. But before that, let me just do a small reflection about metacognition. Metacognition is about the way that we think. It's a reflection on what works for everyone. Everyone learns in different ways, so we have to think about what works for me and what can I improve in order to do this. Some of the important questions that you have to ask yourself is, how can I prepare for this assignment? How can I better prepare for this assignment? And what had it work for me? Usually, metacognition represents the way of thinking about our own thinking. And by doing this, we actually learn a little bit more about ourselves. It is very important in order to become more efficient and less busy whenever we are studying. So now let me talk a little bit about linear algebra. This week we talk about matrix algebra, inverses, and elementary matrices. This becomes very important because most of this becomes a language to describe solutions of systems of equations. What we've been doing is to rephrase all the row operations that we've been doing before in the language of matrices. This becomes very relevant because it is very simple to implement this in computers nowadays. So we don't have to describe with complicated algorithms what we're trying to do. Rather, we can just describe this using matrix multiplications. So working out with matrices becomes very important, and knowing how they work becomes central to what we're doing. This is the main idea of matrix multiplication, addition, and inverses. Some of the most important row operations can be described as either a composition of elementary matrices, which come from the idea of applying row operations to the identity matrix. Once we try to compute a row reduced echelon form, what we are really doing is multiplying by elementary matrices in order to achieve different stages at the very end. One important thing to recognize is that whenever we have a reduced echelon form equal to an identity, that means that our original matrix represents a linearly independent solution for column vectors, which means that if we correspond that to a system of equations, that system will have a unique solution. This becomes very important. On the other hand, in our class of precalculus, we talked about solving inequalities and using this in order to figure out composition of functions. A little bit of what we've been doing in precalculus is to build up a set of different models that we can use to describe the real world. We started with linear functions, quadratic functions, polynomial functions, and rational functions. And now, in order to make these models more complex or more realistic, we are going to dive into exponential functions and logarithmic functions. In order to do this, we need to have a certain properties in order to combine these functions. The idea of combining functions to make more realistic models is used every day in real life applications. In order to do this, the idea of composition of functions becomes very important, and this we can think about as a way of mixing functions one with another. In order to do this, we have to be careful to always have a well-defined domain for these functions. And for this part, solving inequalities for polynomial or rational functions become very important. The idea then is to find places where functions are not defined, and usually that becomes important whenever solving for inequalities. So these are the main ideas that we talked in this week. I hope that this is a little bit more clear and that you stay tuned for the next episode of Math Talk.